Here's creationist Michael Behe to be wrong about evolution again.
I think this brings us to the main thrust of Darwin Devolves, the new science about DNA that challenges evolution. And it seems like a pivotal point of your initial work is that Darwin's mechanisms are not capable of building those complex structures.
Michael Behe's more famous work is a book called Darwin's Black Box, in which he argues that there are biological structures which are irreducibly complex, which means that they are too complex to evolve by minute steps. Tiny mutations building up over time, Behe argues, cannot result in these functional structures, because these structures cannot function at all if you take away even tiny components. The most famous example is the bacterial flagellum. Behe believes that if you take anything out of the little chemical motor that rotates the flagellum, it doesn't work. The problem with Behe's argument is that while a structure may not be able to carry out its current function if you take pieces away, it can often still carry out some other advantageous function. The flagellum, for example, if you take a few pieces away, still functions as a protein export channel in the cell wall, and that's probably what its mechanism developed from.
But Darwin Devolves takes it a step further, and you argue that the natural processes actually degrade complex structures for individual survival. In other words, they do it to survive, but it's degrading in a way that actually impedes evolution. That's devolution, in other words. So did I get that right?
Yeah, that's it. That's exactly right. And many people get confused when they first hear about this because they say, how can you degrade something or break something and have it improve?
This is in no way contrary to what mainstream scientists say about evolution. All mutation is a result of damage to or inexact copying of genes. When those result in advantages, that's not devolution at all. Anytime any organism becomes better able to avoid extinction, that's evolution.
Improve a system. One analogy I like to use is of say, a car. Suppose your life depended on your car getting a little bit better gas mileage. Mm-hmm. What could you do to quickly improve that gas mileage? Well, you can, of course, take off the doors and throw them away. You can take out the back seat or the hood or something.
Throw the spare away.
Exactly. And, those things are useful at certain times, but if your life depends on getting better gas mileage right now, then that's the smart move to make. Yeah. So it turns out that throwing things away and breaking things actually can oftentimes improve your situation. And the new thing that the book emphasizes is that's exactly what we've discovered now in the past 10 to 20 years in the cell, in the evolution of, cells and organisms too. Mm-hmm. It turns out that right now it's like in astronomy where 10 or 20 years ago somebody invented a telescope. Before then, any speculations about what the universe looked like were might have been interesting, but they're superseded by what we now see through the telescope.
Right.
In the same way, science has just in the past couple decades developed the ability to probe down to the molecular level and sequence DNA at a very, very easily in the required detail. Mm-hmm. And it turns out mutations are changes in DNA. They're changes in molecules.
Behe makes it sound like the idea that mutations are changes in molecules is something that's just been discovered in the last few years, when it's been known for at least the last 60 years, probably longer.
Mm-hmm. And if you can't determine what those changes were, then you don't know how evolution is happening, even if an organism seemingly improves. And it turns out that many of the changes that people classically have pointed to as examples of the great power of Darwinian evolution, now we know that they are great examples of Darwinian evolution, but they show broken genes, and broken genes that have beneficial effects.
Again, this is not at all contrary to what mainstream biologists say about evolution. Scientists have used radiation to deliberately induce genetic damage in plants for selective breeding since the 1920s. It has been understood since at least that far back that mutations can be caused by damaging an organism with radiation. This is not new.
So on the one hand, when we were talking about pretensive knowledge a few moments ago, since microevolutionists convince a lot of people that the whole game is accomplished by natural selection working on mutations, they see it on a smaller level, then they just kind of wave the wand over these bigger changes.
Yes, the classic microevolution versus macroevolution argument. Creationists have long tried to convince us that you can produce small mutations with small advantages, but you can't create a distinct new organism that way. This is like arguing that you can take a few steps, but you can't walk all the way down the street. We can see mutations happen, and we can see them sometimes being advantageous right in front of our faces. So creationists can't deny those, so they pivot to arguing that you can't get new species that way, even though we can and have observed organisms speciate over time.
But now when we, without, as you just pointed out, feeling any responsibility to show specifically on a micro level how this took place, because they knew it did, so it must have. But now that we have the technique and the technology to get down really tight to the molecules, now we see that this is a difficulty and it doesn't work the way they thought it did to accomplish the end that they have in mind.
Yes, it does. Scientists have been knowingly damaging hereditary mechanisms in plants since the 1920s to produce advantageous mutations. And now that we can look more closely at what the molecules are doing, we can see that genes are being damaged to produce beneficial mutations, just as we have believed for at least 100 years.
Now, polar bears are the biggest, baddest land predators in the world. And they're thought to be descended from grizzly bears, brown bears, and they're pointed to as swell examples of Darwinian evolution. They went north, became lighter in color to match the snow, and they could eat seal blubber that grizzly bears can't.
By the way, and just notice how you put that, and they became lighter in color. See, This is one of those just throwaway phrases that they only get lighter in color because there's a genetic change. That has to be accounted for. But I understand you're just telling the story. Go ahead.
Yeah, they evolved a lighter color.
Yes, right.
And, well, it turns out that the whole polar bear genome was sequenced about 5 years ago, and the grizzly bear a couple years before that. And the two were compared, and it turns out that the top 17 genes that helped the polar bear adapt to the north are, well, 2/3 of them are broken. That is, or degraded. That is, they're working less effectively, or not at all, compared to how they work in the grizzly bear.
Like throwing the spare tire out, or the seats out, or yeah.
That's right, or throwing out, say, the governor that keeps your car under 50 miles an hour or something.
Again, there is nothing about this that is in any way contrary to mainstream evolutionary theory. And notice that he said 2/3 of genes that are advantageous to the polar bear are degraded. What about the other third of them? They would also have been the product of genetic damage or copying inaccuracies, even if they had nucleotides added to them rather than removed. But why doesn't he see them as having been degraded?
Yeah, the white color of the polar bear's coat results from a gene that contributes to the production of a brown color in the grizzly bear, and when it breaks, it becomes white because there's no color left. And the most interesting thing is that there's a gene involved in fat metabolism, and the grizzly bear or the polar bear eats, seal blubber, which would be toxic for the grizzly bear. But it turns out that one of the genes involved in fat metabolism was broken, and that helped it to eat this large amount of fat.
Right.
So it turns out that the polar bear didn't evolve; it pretty much devolved from the grizzly bear.
Typically, in biology, the word devolution is used to describe the hypothesis that mutations can be reversed, not merely that genes become broken. That's not what Behe is talking about. He's not talking about genes reverting back to old forms, but rather being altered in a way that makes them either no longer have a consequential function or makes them function differently. He says these genes are broken, but that assumes that the gene is no longer doing what it's supposed to be doing, which assumes that there is someone doing the supposing, and I suspect suspect he thinks that someone is God. In reality, nature is not doing any supposing with respect to the function of genes, so there's no basis on which we can say that one mutated gene is any more broken than any other. And it is especially absurd to label mutated genes as being broken in cases when they actually increase an organism's chances of survival.
Okay, so here's a real important question, because as I was reading through your book, Darwin Devolves, and I'm following this argument, this point, the first question I ask myself is, well, isn't that just the Darwinian mechanism of mutation and natural selection?
Yes, that's exactly what it is.
Isn't a broken gene the same as a mutation? And so now there's this mutation that allows the polar bear to get white and to eat blubber where the grizzly couldn't. So how do you distinguish just the standard progression of mutations, which you're now calling broken genes, and the standard Darwinian model from actually a devolution model that you're advancing here based on broken gene evidence?
Well, now that we know about the molecular basis of life, we see that DNA is arranged into genes that have, informational content. They do things, and there are regulatory regions which turn genes on and off at the appropriate times, and all sorts of fancy mechanisms, and we can identify them. We can see, once we have the sequence of DNA, can see which ones do something, which other ones just kind of connect two things together. And so when we ask the question, okay, a mutation has done something beneficial, we can ask the question, well, did it do so by making a new gene or improving it, or what? Or by messing it up, by breaking it. And, overwhelmingly, the data that has been collected so far shows that it's breaking stuff that was already there.
Any mutation that has the consequence of reducing an organism's chances of extinction improves it in the Darwinian sense. There is absolutely no basis on which you can say that a mutation which results in better chances of avoiding extinction is messing anything up.
So improvements would be kind of adding a benefit. Degrading would be taking away a benefit that the gene had, though in a limited scope, it had a beneficial impact on that individual organism.
In which case, you wouldn't simply be taking away a benefit, you'd be trading a benefit for a better benefit.
That's right.
Yeah,
that's exactly right. And in desperate circumstances, you do desperate things. Well, it turns out in Darwinian evolution, everybody's always desperate.
Yeah.
But, you can think of a bridge, construct a bridge from over a river from one place to another. Okay, but now suppose somebody doesn't want you to come over the bridge and they blow it up. That's a change. But blowing up a bridge does not tell you how the bridge was constructed in the first place. It's easy to blow up a bridge. It's much more difficult and involved to construct one.
Yeah.
Whether a gene is added to or subtracted from, the mechanism which does this is still mutation.
Well, go ahead.
Yeah, I was just going to say that's what Darwinian evolution does. It blows up things.
Yeah, and I think the key here, and this is what helped me when we talked last time, is that when you blow up the bridge, you can't get across the river anymore.
Yeah, you're stuck.
And so it's kind of like sending something down an evolutionary dead end. So it results like the vehicle that moves faster because it doesn't have a spare tire. It results in short-term gain. But in terms of long-term benefit, if you need that, you have a flat tire, you're out of business. Because you don't have the spare anymore. And so it's kind of like going down a dead end. I think that the way I'm thinking of it is that breaking a chain gives short-term gain, but it limits the long-term evolutionary novelty or the opportunity for novelty that is required to move the entire project.
Not true. Mutation can add nucleotides as well as subtract them, and genes which are altered to no longer do anything can be further altered to do something again.
Forward.
That's exactly right. You adapt to new circumstances, but you become more limited by doing so. Think of the polar bear again. It's doing fine in the Arctic, but suppose global warming comes along and it turns into a jungle or something.
Yeah.
Its white color, which it's stuck with now, is not going to be a benefit in the jungle, and yet it's, that ability was blown up and thrown away, and so it's much more likely to go extinct than to survive.
Even if mutations which subtract from genes are more common than mutations which add, further adaptation can be achieved by further subtraction. For example, polar bears actually have very dark skin. If the environment gets warmer and they need camouflage for a forest again, a polar bear with a mutation that subtracts from the genes that cause hair growth and renders them hairless will result in that camouflage. In fact, if the Arctic becomes a warm jungle, maybe having less hair would grant more than just a camouflage advantage. So even if subtraction mutations are more common than addition mutations, I'm skeptical that this reduces an organism's ability to adapt to environmental changes over time. And I'm even more skeptical that divine intervention is necessary to overcome this reduction in adaptability. To everyone who helps me out on Patreon, you're a big help. Thanks so much.